Hi everyone, my name is Min, and today I will discuss about problem 824 of homework 5. So the problem asks us to determine the rate order and the rate constant of the reaction of decomposition of dinitrogen pentoxide at 45 degrees Celsius using the data collected below. So there are a few concepts that you need to understand before approaching the problem. So first is the rate law, R equal K times A to the X times B to the Y. So the reaction rate is the change in the concentration of the reactant or the product over time. The reaction rate law expression relate the rate of the reaction to the concentration of the reactant, where K will be the rate constant, so it's proportionally relate the rate of the reaction with the concentration of the reactant in respect to time. X plus Y will be the rate order. So as we discussed in class, we have the three main order for now, so which is a 0, first and second order. So I have it right here is the integrated rate law expression, which showing the instantaneous concentration of the reactant with respect to time. So for 0 order, A will be equal to negative KT plus A naught. First order will be natural log of A equal negative KT plus natural log of A naught. Second order, 1 over A equal KT plus 1 over A naught. So for our problem, which is a decomposition process, so 2-dinitrogen pentoxide gas will give us 4 nitrogen dioxide plus oxygen gas. So as we discussed in class multiple times, since it's a thermal decomposition process, I will hypothesize that this reaction will be a first order reaction. So based on our hypothesis that it is a first order reaction, I have the integrated rate law right here. So again, natural log of the reactant will be equal to negative KT plus natural log of reactant at time 0. I also have a linear form of expression, so y equal mx plus b, and so based on here you can see the correlation between those two. So y will be equal to natural log of a, the slope of the graph will equal to negative k, x will be t, and b will be natural log of a0. So from those expressions, in order to plot the data, I need to convert it first. So I convert the concentration of dinitrogen pentoxide into the natural log of it using Excel. And as you can see right here, there are a lot of significant figure, and I want to keep it in order to have the most accurate graph. And so now we just plot it. So the y-axis will be the natural log of the partial pressure, and the x-axis will be time. So you can see right here, the R-square value is really good. It is equal to 0.995. So it shows a really accurate data as it's approaching to 1. Because really close to 1 is a really accurate graph. So based on our equation, the slope of the graph is equal to negative 0.0299. So as slope equal to negative k, our rate constant will be 0.0299, and the unit is a concentration over time. So in here will be torr per minute. So in conclusion, this is indeed a first order reaction, and the rate constant will be 0.0299 torr per minute. Thank you for your time.